Welcome to myprojectbazaar.com. Now we can going to discuss about the project, a multi-objective optimization technique to develop production system of distribution network with distributed generation. Now we can going to discuss about the abstract of a project. In distribution generation was developing the efficient system to in our system of IEEE 30 bus system. We can use that. In our base paper we can use the 119 bus system, can use that, but our implement take only for 30 bus system. This is an installation of DG's influence of our calculating the power stability and the transient stability and find out the real and reactive power losses, which analysis the purpose. And next we can two objectives of in our systems. First one things on network continuity. Network continuity means any fault occur in this particular region of buses or not. We can find out the process. Another thing is an network cost, total cost. We can find out the total cost of the network for distribution networks, for also production device also. So some production device available for relays and circuit breakers, we can use that in our parameters to take that. So our economic issues and network connectivity can interrupt our interruption will or in system is not given or not, so that we can using the optimization technique of non-sorting non-dominant sorting genetic algorithm. Use that in this methodology for operating the 30 bus system. Next we can going to discuss about the flow diagram of our project. First we can see about the IEEE 30 bus system. In 30 bus system here use the bus data, line data and the generated data and the generated cost functions. We can all are given in the IEEE 30 bus system. So we can take the different data, we can call that, and you just use a separate of data. Example, we can take the susceptance value or resistance value, take the line data, or bus data we can take the voltage magnitude or real power generation or reactive power generation. We can all our values are stored in IEEE data in bus system. These data are passed into the data functions. The data function is nothing but we can call this a particular region of the lines or load. We can apply that. Data function is one of the method. So the data function is passed to the optimal power flow. In the optimal power flow methods and three methods are used, but we can use the Newton-Raphson power flow method. The Newton-Raphson power flow method is a very efficient method. For that, our convergence is very easy, but iteration time is very high. But our system process, our optimal power flow, using that, check the continuity of 30 bus system. Using that is passed through the non-dominant genetic algorithm. This is a multi-objective non-dominant genetic algorithm. Because of multi-objective means we can sending the two objectives. First is network continuity, another is cost functions. So we can pass the analysis purpose of optimal power flow method of Newton-Raphson. This passing to the non-dominant jotting genetic algorithm. This is multi-objective algorithm. So we can process to the network continuity and check that all network continuity in all buses. Any interruption in any lines or check that is an if an interruption line is an is totally zero because of some fault or occur in the some particular region. Fault means I told that some similar and unsimilar fault. For example, we can take the line to line fault. Apply that regions. So this is one of the objective. Another objective you can call that objective cost functions. The cost functions are nothing but we can overall cost of the our system. Our cost is an efficient, our system also efficient. Some economic issues we can use that. We can production device also provided that our 30 bus system. So our system has an efficient and continuity also fully monitored. So this is our entire system of the process. This is our flow diagram of the non-dominant jotting genetic algorithm. First we can see the population initialization. We can our data are imported in these sections. We can calculate the objective functions. We have two objective functions. First one is a network continuity and another is an economic issues of the entire system. So this is on two objective. You can use that this block is passed to the some conditions will given to the criteria will occur that it will okay, or sometimes we can satisfy or not we process through again we can call that population initialization. So we can again continuation looping process. This is satisfaction is completed. This also goes to the population termination. Else the fitness function is distributed. The fitness function take the some fitness value will take that. So this is a reference value to apply our two objectives. For that I take the economic issues. This is one of the condition achieved that after we can proceed to the genetic algorithm process. We can genetic algorithm process have four steps: population initialization, crossover, mutation, and selection. So this processor will update that on different chromosomes. We can use that the sections. So another we can insert the parent nodes. We can updating again total algorithms again we can rotating that these steps. Now we can going to discuss about the running process of the our project. First we can develop the MATLAB version 2013A of the this entire system. We can first create the new script file and creating the codes of this element. We can using these blocks. We can develop in the user interface design guide design. We can also use that. Open the main.m and execute that. We can one of the user interface block we open. This is on our bus data. We can calculating different data for number of buses or number of bus type is an slack bus, PV bus or PQ bus. So different buses run of this entire system. And this is an voltage source voltage source voltage means voltage magnitude and voltage angle and real power generation, reactive power generation. So we can find out the different types of bus data values. As per we can calculate as a reactive power also. Next we can see the line data of the process. Line data we have some transmission lines losses will occur that. So some resistance and reactance in this every lines. So this is an resistance and reactance of this line of entire system. And susceptance value also declare that, and transformer ratio will declare that. So we can line data will also find out that. Another is an main our objective of the process. This is an our entire power flow of the process. Power flow means our check the our network continuity. Example we can take the bus number 5. Bus number 5 is an normally to take the voltage magnitude also perfect, and the angle is an, too much also non-linear. But our system has an not for reduce the losses, but system is an continuously power flow, no interruption in this in these lines. So angle is on some minus or plus values will randomly generated as per our optimal power flow using that Newton option. So we can some values will generate that. This is on our remaining lines. This value is on nothing but our fitness value. Our fitness value is on to take that non-dominant genetic algorithm of the objective of the power flow process. These are our fitness values. This is an cost of the equipment and number of lines. Example we can for 41 lines we can using that. If I example I can connect the 30 bus system, 13 bus system to operate the some loads are connected, how much we can generating the power of load. So we can ask that process. So we can connect the different lines, and this is an our cost of equipments. These are also all are in per unit levels. This is an up and downs of a very non-linear graph, but this is an our find out the cost of function of the entire system. This is an our non-dominant genetic algorithm process. So step the iteration to take on 5, and a crossover operation and the mutation operation values are declared that similar that, but we can take the 5 iteration levels of a genetic algorithm process, and this is our fitness value. Again this is fitness value, optimal fitness value, optimal fitness functions, and there are some difference to that line.